Welcome to another session of our Learning Together series sponsored by the Rassis Brosis Foundation. I am very excited to share another topic with you. And this has to do with solving quadratic equations by using the method called completing the square. You know, there are several methods that we can use to solve quadratic equations. We could use graphing and see where the quadratic equation cut the x-axis, and those 2 points of intersection would be your solution. And of course, if the graph doesn't cut the x-axis, then you would have a problem because it means that you have imaginary solutions. Then there are some quadratic equations that you can solve using factoring. But the truth is not all quadratic equations can be factorized. So that has limits. But if it can be factorized, it's a very quick and easy method. Then of course we have the good old quadratic formula, which I dealt with the last time we were together. And today I'm going to add to the toolbox one more skill. It's called completing the square. In order to be able to use completing the square effectively, there are a couple of skills that we must have good control over. One is factoring. Two is the zero product property. The zero product property. Three is radicals. And of course, four would be square roots. I will go easy on radicals until another topic. But today I'll just take you as far as we can go, and then we'll pause right there. So, what does completing the square involve? I'm so glad you asked. Before I actually go through the process, I'm going to go back to dealing with perfect squares. For example, x plus 2 squared. That is a perfect square. It's one binomial times itself. It is a perfect square. Whenever you expand that, you end up with x squared plus 4x plus 4. In a previous session, we practiced how to multiply binomials by using FOIL or just sequentially, systematically, just multiplying each term in one binomial times the terms in the other binomial and just combine like terms. That's how you do it. So we're not going to go through that today. That's already completed. Another one, if we have x plus 1 squared is equal to x squared plus 2x plus 1. If I gave you x plus 3 squared, it's equal to x squared plus 6x plus 9. What I'm trying to do is I'm trying to list a few expansions of perfect squares, and hopefully we can see a pattern on the right side. So keep watching. So if we did x plus 4 squared, you're going to get something like x squared plus 8x plus 16. Let's try 2 more. X plus 5 squared is equal to x squared plus 10x plus 25. And I finally want to do this one, x plus 6 squared